Okay, welcome to Calc 2. So today we're going to talk about 12.6. We're going to talk about Newton's method. Okay, so what we're doing is a picture. Okay, and my drawings are going to be terrible here, so forgive me for this. All right, is we're trying to find zeros. Okay, in the 21st century, this is not as much of a skill that's needed as it was in the 20th century, because your calculators tend to do this, but this is understanding like how the calculator is doing this. Okay, so the first thing we want to do, say we have a curve, and you are given some point here. Okay, we don't really know what this graph is going to be looking like. We don't know any numbers, and we're given some other point here. It doesn't have to be symmetric. This has to be on one side of a zero and another side of a zero. Actually, I'm going to go ahead and change this already. Okay, and we'll do a little thing here. So we'll do a value, say here, and a value here. Okay, and whatever the f of x value is, okay, so this is my f of x, what you're looking for is, if I pick this point, I end up with a negative number, so f of, we'll say a, okay, this is less than zero, so it's a negative number, and then b, we'll say here's f of b, and happens to be a positive number. Well, if you have a polynomial, if you have any function that happens to be continuous, okay, it has to be continuous because you don't want it to jump, okay? It stands to reason that if we were negative here and then positive, it's somewhere in the middle here, there is a spot, there is a zero. So some f of c is equal to zero, okay? It went from negative to positive, it had to cross somewhere, okay? And then again, assuming that this is continuous, okay? So what we're going to be doing is we're going to make a guess, okay, which could be B or A, or if you want to pick something else, you can. But generally, you want to pick your B or your A. I'm going to pick whichever one happens to be closer to zero, but it doesn't really matter. So the time where it does matter is if you pick a point that is too far away, you might catch another zero, okay. And there's some other issues depending on what kind of value you have. So if you happen to catch something that like happens to be close to a max or relative max, this could tell you where the max is, so to speak, but not where the zero is. So you have to be kind of close, but not super close. Okay. So it's kind of like the same idea. Like, if I ask you, what's your electric bill? Like, I don't know. Well, is your electric bill $100 or $500? Well, it's closer to $100. It's closer to 100 or 200. Well, it's closer to 100. So that's a good guess for your electric bill. But you wouldn't want to guess 500 because like there's no bill out there and it might not exist. So you want to get close, you want to get in the ballpark, but you don't have to guess real close. Okay, it's the same idea as like when you go grocery shopping. Like, do you know what your amount is going to be when you get to the cash register? Okay, I typically kind of know because I've had to have that kind of a tight budget for a while, and I just got in the habit of doing it. So I just add as I go. Am I exactly? No, no. And as I've gotten more comfortable with my bank account, I don't have to be quite spot on anymore. So I've gotten lazier about it. So for my thought, it's like if I'm within $5, it's good enough. Okay. So that is that's the kind of guess you're making. So when you make your guess here, okay, what we're going to do is we're going to have our function value, and what we're going to do is we're going to get the slope here, okay, and just pretend this is the slope. It's not really the slope, okay, that we're going to use our slope. We're going to kind of drill down to like get a number that's close to that zero, and then we're going to figure out what happened for the f of x at that value, and then reapply, okay. And then what if we overshoot it? That's okay, because we're just going to come back up here, right? We're going to come back up here, and then we're going to figure out like what's going on with this slope. And then eventually we're going to get closer and closer and closer and closer into our little slope. Okay, for some functions, it'll look like a little spider web here to kind of get what we're supposed to do here. Okay, for the most of the problems you're going to have, they should converge, i.e. they should get close enough to zero so you have an accurate answer. within about 3 or 4 steps. I wouldn't build a problem that would need more than 4 steps here. Okay, it's going to get a little tedious. And yeah, I just remember spending an entire airline flight doing this one time because I was bored and there was literally nothing else to do on the airline flight. So yeah, like, hey, figured out the square root of 2 to about 10 decimal places. All right, you got it, Chief. That's what I'm going to do this to spend the 8 hours on the airplane today because there was literally nothing else. Okay. So there we go. I think I was reading a Dan Brown book and I kind of got tired of it after about the 3rd chapter. I was like, it's the same thing you read last time. Okay, Dan Brown never watches this. Sorry. Okay, so let's go ahead and figure out like what is a close zero for this. Okay, so let's just take it as you're supposed to do for the time, getting to the end here. So here we have a function. We have 2x squared minus 4x minus 5 equals 0 on the interval, and they're telling us like it's going to happen somewhere between 2 and 3. Okay, and normally, pick easy numbers to go through this. So if you actually had to go through this even one step back, you would just start plotting 1, 2, 3, 4, and see where the thing actually got between 0 and or between negative and positive. You could probably do something like, well, does it happen between -5 and +5? Does it happen between 0 and 4? Does it happen between 2 and 3? That kind of thing. So you would want to narrow it down a little bit. Once you get down to 2 and 3, so this is 2 squared minus 4 times 2 minus 5. Okay, we'll go ahead and do a calculator thing here. So we'll say 2 times 2 squared. There we go. Okay, minus 4 times 2. Yeah, minus 5. Enter. Oh, did we equal something? Looks like we did. That's -5. I hope. Okay, and then we're going to check in for what about 3? Okay, so this was f of 2. This is going to be f of 3. So we're just going to plug in the same formula here. We're just going to say 2 times 3 squared, okay, minus 4 times 3, right? Minus 5, and hoping that this actually works, then we end up with 1. Well, -5 is negative, 1 is positive, so somewhere between 2 and 3, there had to have been a y value that's 0, okay, because it's a parabola, it's continuous, okay, we had to have crossed 0 somewhere in here. Okay, so that's one of the big things you're supposed to be looking for. Okay, now what we're going to do is we're going to make a guess. Guess 2 or guess 3. I'm going to guess x equals 3. That's close enough to 0. And what we're going to do is we're going to say, okay, well, 3 minus, and we have our f of 3 divided by f prime of 3. So what's happening here is we're saying, well, here's our value, and here's our value, and we know it's a thing in here. So what we're going to do is we're going to go ahead and track down the slope here and figure out what the value is here. And then we'll come back up, and that'll be our new value. Okay, and then we'll go ahead and guess here. From here, this will be our next guess, and we'll track this down again and see how close to 0 we can actually get for our f of x here. Fortunately, if you ever take a numerical methods class, you'll learn that parabolas tend to converge pretty quickly. Okay, so that's a nice first problem. Okay, so what is the, okay, so we're just going to write down, so this is 2x squared minus 4x minus 5. That's my f. What is my f prime? Okay, and then we end up with, take the derivative, so that's going to be 4x minus 4, it looks like. Okay. Just double checking to make sure. Yep, 4x squared, 4x minus 4. So the formula we're going to be doing here, okay, is 3 minus, okay, and this is going to be 2 times 3 squared minus 4 times 3 minus 5. divided by 4 times 3 minus 4. I got that because of this guy right here, the derivative. Okay, so that's the formula for it. And this is our C1. This is our first guess. As soon as we generate this, we'll get an answer. We're going to use that. So that's this point right here. I know it's hard to see because the drawing is terrible. Okay. We're going to get this point. So after we trace this down to the origin, we're going to go to this point. And then again, we're going to figure out what this point is and then keep going until we get to a 0. Okay. So we're going from here. We're trying to get to this point here. That's what's going to give us this. Once we get this point, we're going to reevaluate the same system because we want to kind of follow the slope down. Okay, but we're going to follow it from here rather from anywhere else. Okay, so let's see what we get. We get, let's go 3 minus, okay, and we already know what this is going to be, don't we? Because we already typed in 2 times 3 squared minus 4 times 3 minus 5. Like, oh, look at that, that's 1. Okay, divided by, and then we have 4 times 3 minus 4, so that's going to be 12 minus 4, so that's going to be 8. That's going to be 8. Okay, so 3 minus 1/8. I would say we could do this in fractions, but I know it's going to be a disaster about the second time through. So we just have 3 minus 1 divided by 8. And the book says, you shall keep 4 decimal places until you are done. So this is 2.875. And then that's going to be our next point. Okay, so we're going to say 2.875 minus, and now we have to do this all over again. So this is 2 times 2.875 squared minus 4 times 2.875 minus 5 divided by 4 times 2.875 minus 4. Okay, we're just going to go through and crunch that on into doing this. Normally, I would say like you would want to use Excel for this, but this is kind of a small problem. So I don't know if you want to bother with Excel or not, but we're just going to say 2.875 minus, okay, and now we're just going to have, well, actually, you know what? We're just going to keep 4 decimal places, so I'll just do it in pieces, and then we'll just see what we have here. So this is going to be 2 times 2.875, 2.875 squared, okay, minus 4 times 2.875, okay, minus 5. So that was 0.03125, 0.03125. You see, if I just plug this in, we get 0.03125. So to 2 decimal places, this is already close to 0. Okay, and then we have 4. What are we doing? Okay, so we have 4 times 2.875, okay, minus 4. So this is 7.5 on the top here, on the bottom. So what we're going to do is we're going to say 2.875 minus, okay, 0.03125 divided by 7.5. Okay, and that's going to be our next guess. So our next guess is 2.8708. Okay, and I'm following the instructions in the book that says you will keep 4 decimal places. So 1, 2, 3, 4, 2.8708. That'll keep down the arithmetic a little bit. Okay, so let's go ahead and do this one. So we have, this is 2.8708 minus, and then we're going to say 2 times 2.8708 squared minus 4, 2.8708 minus 5 divided by 4 times 2.8708 minus 4. Okay, and then we'll get that answer. Okay, so this is 2.8708. Actually, let's go ahead and do this. We have 2 times 2.8708 squared. Okay, minus 4 times 2.8708 minus 5. Let's just see what that is, okay? So we have negative 2.01472. Okay, if I use scientific notation, that's fine. But since since they wanted the 4 decimal places, we'll just do that. Okay, but this is starting to get really close to 0. So I'm pretty happy that this might be the last time I have to do this. Okay, so this was negative 0.00. What do we have here? 4 points. So we have negative 2.1472 times 10 to the negative 4th. So this 1, 2, 3, 4. So the 4 decimal places, this is 0.00, negative 2. Okay, 0.00, negative 2. Okay, divided by, and here we have 4 times 2.87. I'm just doing this one for completeness. Quite honestly, once you see this one here, like to 2 decimal places, our answer is supposed to be 2 decimal places. 2.87 will give us this answer in this polynomial. That's what they said is close enough to 0 is 4 decimal places. So at this point, we're kind of done. Okay, you don't have to do the rest of this. Okay, because it'll take this answer and say, oh, I guess it's close enough. So that's what we have. So if you needed to do one more, if you wanted to do one more, you just like completeness here. This is going to be 7.8.4832. Okay, and what are we going to have here? We're going to have 2.8708 minus, and then I'll show you with this one. So this will be minus. It's going to be minus a minus. Okay, so that's a negative thing, so it's going to be a positive here. So we'll say positive, and then we have 2.1472. Do not forget to type in the times 10 to the negative 4th. That's second function, comma. So this E thing that gives you the E. Don't use alpha E, that's different. Okay, we want times 10 to that second function, comma. Okay, divided by, and then we have 4 points, or 7.48, 7.4832, and we'll go ahead and take a look at that. Right, and then this is our new answer. So 2.8708, and then 28694. I don't know if I typed down the whole thing here. I did it before. I'll probably find it here though. I'm pretty sure can. Okay, but you can see how close these numbers are. I mean, it changed in the, down here somewhere. So way beyond the tolerance of what they asked for. If they just wanted the 2 decimal places, we were done. Okay, 2.87, that's all they wanted. That'll give us a close enough to 0 that they have here. So we're going to type in 2.87. We're going to call that f of this thing is going to be 0. We're close enough to 0 that we can't really tell the difference. Okay, so that's what we want to do for Newton's method. Okay, so let's see if we can find one more. Oh, they give us 2 of them. Okay, that's nice. Okay, let's see if we have one that's a little bit more interesting. Oh, there's an e to the x. Maybe we should do that one. Newton's method to find the nearest root to the nearest thousandths. Okay. Yeah, that's what we did. Okay. What do you guys want to do? Let's do the cube root of 87. Okay, so how do we find the cube root of 87? How accurate do we want to be to the nearest thousandths? Okay, so to 0.001. All right. So to get this answer, to get a function, x cubed minus 87 equals 0. Okay, so it's, well, x equals the cube root of 87. I don't know. Cube both sides, so we get x cubed equals 87. And then we're going to make a function out of it, x cubed minus 87 equals 0. And this is what we're going to try to solve. Okay, so these are a little tricky just because you kind of have to do this. I'm not asking you, if you ever see this thing on a quiz or anything like that, we're not asking you to type in and say, oh, what's the cube root of 87? We know what that is, all right? I'm not saying you can't peek and say, well, the answer is going to be close to. Okay, you can certainly do that. But when I do this, I want to see something like, well, we have to guess. How would we guess this? Well, I know that 4 cubed is 64. 5 cubed is 125. 87 is somewhere between 64 and 125. So we'd have to guess one of those things. So why don't we guess the cube root of 87 is x equals 5. Okay, and it's a horrible guess. Okay, but it's better than 10, right? It's better than, well, I think it's 1. It's not going to do that for us. Okay, so we want to get somewhere close. Generally, you want to say, well, cube root of 4, or the cube of 4, cube of 5, 87 is somewhere between there. So our guess is going to be 5. All right, so our function, okay, x cubed minus 87, okay, f prime of x is equal to 3x squared. Okay, so we're going to have our guess 5 minus, all right, and we're going to do f of 5 over f prime of 5. Okay, so this is going to be 5 minus, and we're going to plug in this guy here. We're going to say, okay, this is 5 cubed minus 87 divided by 3 times 5 squared. What's that equal? Okay, so this one's a little bit nicer to deal with because the numbers are not terrible yet. Okay, so this is going to be 5 minus, and what is 5 cubed is 125. Okay, 125 minus 87. Okay, and that's 38. Okay, and then 3 times 5 squared, that's going to be 75, right? So it's 25 here times 3, 75. I'm going to do it in decimal places simply because that's pretty much the realm we're dealing with. I'm not going to worry about fractions so much. Okay, so this was 5 minus 38 divided by 75. Yep, equals, we got 4.4933, 4.4933, right? So that's our new guess. Okay, so our next point is going to be 4.4933. Okay, we want the nearest thousandths. Intermediate values to 4 decimal places. So, okay, we're good. Okay, and this would be, okay, 4.4933 cubed minus 87 divided by 3 times 4.4933 squared. Okay, so same formula we did here, just with a new number in it, right? So let's see what we get. We got 4.4933 cubed. Oops, I want to do this one cubed. Okay, cubed, not to the 6th, good grief. Okay, and then minus 87 because that's the one we're trying to find. Okay, so that was 3.718. Okay, and some change. Okay, divided by 3 times 4.4933, 4 point, good Lord, 4.4933 squared. Okay, the squared will happen first, then the multiplication, and then the division. Oops. Okay, so we'll take this number divided by that number. Okay, so we got what? Come on. So we're going to have 4.4933 minus, okay, 0.0619, I'm sorry, so 0.061, we'll call that 4. So this was 0.0619, we'll say 4 here. Okay, and then we'll go ahead and look at this. We'll say 4.4933 minus 0.0614. Okay, enter. I got 4.4319, 4.4319. Okay, so this is going to be our third, this is what we had guessed. First guess was 5. Second guess was 4.4933. So you can see, right? Look at our numbers we guessed. We had 5. We had 4.4933. We had 4.4319. So 4.4 is probably set in stone here. Okay, then it's going to start changing in these decimal places again here. Okay, 4.4319 minus, and then we have 4.4319 cubed minus 87 divided by 3 times 4.4319 squared. But let's see what happens. Okay, so what we're going to do here, 4.4319 cubed, okay, minus 87, okay, we'll say equals. So we're getting pretty close to that value. We're not too far off. But then we're going to do a follower slope down. So we're going to do divided by 3 times 4.4319. Okay, 4.4319. This is going to be squared. All right. So I'm happier about this one because it's getting to be a pretty small number. Okay, so we have 4.4319 minus, okay, and this was 8.522. 8.522 times 10 to the negative 4th power. Okay, so we're going to take 4.4319 minus my previous answer. Okay, not going to be very much. We ended up with 4.431. 4.431. I'm going to go ahead and round it to the 0.0, the 4th here. Right, typical rounding rules, that's going to drop off to 0, right? Because we're trying to round to this 0 here. So 1, 2, 3, 4th power, and then this one's not going to matter. Okay. So I think if we go through and do that, I think we're going to get to the nearest thousands. Okay. So this should be 4.431 should be our value. Okay, but let's try it. Let's see if that's going to be working. So if I take 4.4311 cubed, okay, notice we try to look for 87. So we're still 0.003. Okay, so we might want to do one more just to see, but it's not going to change very much. Okay, it really isn't. So I'd be surprised if this changed at all. But let's try. Okay, so this is 4.4310 minus, okay, now we have 4.4310 cubed minus 87 divided by 3 times 4.4310 squared, right? So let's see here. We have 4.4310 cubed minus 87. Okay, that's going to be a small number, right? And then we're going to divide by, okay, and we're going to divide by parentheses 3 times 4.4310 squared. Okay, so here we have 4.4310 minus, which is really going to be a plus, okay, 4.7622 times 10 to the negative fifth. I don't think this is going to change anything. Okay, so we have 4.4310. I'm going to say minus because that'll turn it into a plus, okay, but we'll just use our previous answer, okay. And notice like this didn't change, okay, 4.43104, okay. So we could have stopped right there, okay, 4.4310. Or 4.431. Okay, so let's have a look. So this was 4.431. Okay. So I put in the thousands, tens, hundreds, thousands. I think I only need to do that one. It'll yell at me if I'm wrong. Okay, so there we go. Okay, but that's how you find square roots and cube roots, etc. But you don't have a good calculator. Okay, and that's how we used to do it too. Well, not we, but this is how it used to be done. If you ever watched the Hidden Figures movie, first off, they talk about Euler's method, how to solve something. It still blows my suspension of disbelief that they didn't use that before, but I was told I was being too critical. Okay, that's fair. Because Euler's method's really old, and it's used a lot for solving differential equations that you can't solve analytically. But I guess back in those days, you would do everything you could to solve them analytically because that was the only way you could go. So that's fair. But this is what we did. This is what people did. Mostly women, because they had the job title of calculator, which means they had to know this much math in order to do this, and they would just compile books upon books of how to get cube roots of different numbers. And then you can look. These still exist, but you're not going to find them for sale. You find CRC books, and this would list like cube roots, fourth roots, etc. Anything people needed in order to get this, and that was the job. Again, mostly women would be the the people to run these calculations and to publish these things. Okay, and then just to make sure that all the women in the class are going to be suitably upset, then man will put his name on the title and publish it. So that's exactly what happened. So yeah, not the best thing, but that was the thing that was done. Okay. Okay, I think I'm going to make another video and show you like when it doesn't work out so well. Okay, because you can get worse as we go. Okay, so you have to be careful with this. So I'll see you in the next video. Thank you for coming along. And then we're going to go with that. Goodbye.